Good morning, children. Today we are going to study about the continuation of radicals. Okay. So what was radicals? Radicals are an atom or group of atom containing a fixed charge, right? A fixed charge are called radicals, or in other words we can name it as ions itself. Okay, an atom or group of atom containing a fixed charge is called radical. And some example we have studied was hydrogen radical H plus containing a fixed charge, or chlorine radical Cl minus, then sodium radical Na plus, or oxygen radical O2 minus, or okay, like this one. So the radicals which containing only one atom in them, only one number of atoms, are known as simple radicals. Okay, what are simple radicals? The radicals which contains only one atom in them are known as simple radicals. Okay, so the examples are H plus ion, Cl minus radical, Na plus radical, or O2 minus radical. So instead of radical, in the coming chapters I will not name it as radical, I will name it as ion only. Hydrogen ion, chlorine ion, sodium ion, and oxygen ion. Like this only I will be explaining. So the radicals or the ions containing only one atom in them are called simple radicals or simple ions. And what is compound radical? The radicals containing two or more ions atoms in them, like SO4 2 minus sulfate ion, okay, NO3 2 minus nitrate ion, or OH minus ion. So the atoms containing radicals containing two or more atom in them are known as compound radicals. Okay, are known as compound radicals. Clear? What is a radical and what is a simple radical and compound radical? So up to here we have completed yesterday, and today we are going to study what is an acidic radical and what is a basic radical. For that, here I have taken one example. HCl is reacting with NaOH. What is the name? Hydrochloric acid reacting with sodium hydroxide. So when an acid react with a base, what it will form? Salt and water neutralization reaction. Okay, in your 8th standard we have studied this. So in this during the formation of sodium chloride, we know that they are containing one positive charge and one negative charge. We will always write the positive element first and the negative element at the second. All the cases, not only in sodium chloride, in chemistry, if we have to write a formula, we have to write a chemical formula, the first element we will be writing will be a positive element, and the second element we will be writing will be the negative element or the negative radical. So here in the case of sodium chloride, the sodium is positive and chlorine is negative. Okay, sodium is positive and chlorine is negative. The radical which is positive in nature is called cation. The ion which is positive in nature, I told this plus symbol, you have to remember this plus symbol. cation. Cations are positive in nature. Okay, so the radicals which are positive, okay, are known as cations, and they will always show they will always show basic property. All the positive charged radicals will show which property? Basic property. So they are also known as, the positive charged radicals are also known as basic radicals. Okay, what are basic radicals? The radicals which will show the properties of which will have a positive charge are known as basic radicals. Okay, they will show the property of base, they will show basic property. Okay, so understand. So what is a cation? Cation means a positively charged radical or positively charged ions are known as cation. They are also known as basic radical. Why they are known as basic radical? Because they will show the properties of base. Okay, and here sodium is a basic radical, Na plus, and chloride Cl minus. What about Cl minus? Cl minus will be is a negative charged ion, so it is known as anion, or it is also known as negative, it is a negative radical, it is known as anion, or it is also known as acidic radical. Okay, anions A and acidics A, both will be, you should keep in mind like that, anions will be acidic in nature. Okay, this A and A, don't get, so that time you will not get confused. Okay, keep in mind about this A and A, anion, acidic radical. Okay, cation, basic radical. Clear? Why they are acidic radical? Because they will show the properties of acid, because in acid HCl, what is present? Chlorine is present, so it is an acid, so it will show the properties of acid. Okay, negative radicals will show the properties of acid, and positive radicals will show the properties of base. Okay, so that I have explained here. In NaCl, Na plus radical and Cl minus radicals are present. The positive radicals are called basic radical, whereas the negative radicals are called acidic radicals. Clear? So in your textbook, same topic is explained with potassium hydroxide and hydrochloric acid. No need, this example is enough. I think this one is easy for you. That is why I have given this example. Okay, then one table is given in your textbook, page number 6. Okay, in page number 6, one table is given. In this, I have put some tick mark on some elements. These elements charge, their radicals are given here. That you don't want to by heart, but you have to keep in your mind, because in the coming topic it will ask, write the formula of ammonium hydroxide, or like that, any compounds formula you have to make. So if you have to make a formula, you have to by heart these charges, or this number. Here it is only plus, that means plus 1, only charge is 1, or instead of charge we will tell valency, or the valency will be 1. See, here it is silver. In exam it will ask, write the formula of silver nitrate. So if you have to make the formula of silver nitrate, you have to write by heart the formula of charge of silver, Ag2 plus, that 2 you have to remember. Otherwise if you are writing any another number, that formula will be wrong. Okay, so which all I have put here tick mark. Okay, either take a screenshot of this and mark the same in your notebook also, textbook also. Okay, so this one I will zoom it now. So what you have to do is, either you pause this video and mark that in your textbook, otherwise take a screenshot. Okay, take a screenshot of this in your phone. Clear? Otherwise if you are using mobile phone, laptop, you take the cut that portion using snipping tool or anything. Okay, cut it, then you can paste it, copy, save it in your any folder. Okay, so zoom it and mark it in your textbook. First table, this much elements you have to study. Other which I have not marked, that is not compulsory to by heart. Okay, these elements you have to keep. Many of the elements charge you know, because you have studied in your smaller classes. Remaining things you just keep in your mind only. And here it is the second table. It is our second table. In this also, which all I have marked, that all you have to study. First table are showing only cations list, positive charged radicals. Second table is showing only anions. Okay, clear? So this much you have to study. At least this much you have to study. From this, sure question is coming in. Last year also 5 mark question was there from this topic. Okay, so mark it. And now we are going to study how to write a chemical formula. How we will write a chemical formula. How we can make the formula of some element. So one example I have written here. Write the formula of calcium chloride. So some steps are there. Simple step only. First step, write their symbol. Write their symbols with their valency or charge at their top of the side. Top side you have to write their charge. So our element is calcium oxide. So the first element is calcium, and calcium chloride. First element is calcium, second element is chlorine. Okay, so one calcium we have written, chlorine we have written. Okay, their charge 2 plus and 1 minus. How you will study this? How you will remember this charge? For that I told you to study this table. See chloride. See the charge of chloride. Chloride minus Cl minus. That means Cl minus 1. Okay, and calcium. Calcium will come in positive page. See, calcium. Ca2 plus calcium. So this one you have to by heart, otherwise you will not be able to write any formula. Simple only, simple tricks you use by yourself and study this. Okay. So calcium Ca2 plus and chlorine Cl minus. So what we have written here? First of all we have written their symbol, and at the top we have written their charge or their valency Ca2 plus and Cl minus. And the next step is cross give the values without charge. So next step what we have to do is, here one charge is there 2 plus. So that charge we don't want to use in the next step onwards, only that number we have to use. So next step is the charge, the number, the valency of calcium will be given to chlorine and the valency of chlorine will be given to calcium. Okay, cross giving the values. So that time how it will come? This minus 1 will come to calcium. So Ca1 and Cl2. 1 we will not represent anywhere. So what is the formula of calcium chloride? CaCl2. Understand? Calcium chloride. Like this way we will write their formula. First step is write their symbol with their valency at their top. And the second symbol will be cross give that valencies. That time the valency of the first element will go to the second element and valency of the second element will come to the first element. Okay, then if it is 1 means 1 we will not represent anywhere. So we can write it as CaCl2. So this is the formula of calcium chloride. Okay. Then one more example is I have taken, that is magnesium oxide. So first step is write their formula Mg, write their symbols Mg, oxide O with their charge or valency at their top. So what is the valency of magnesium? What will be the valency of magnesium? If you know the valency in the smaller classes last year, I told you to study the formulas of these elements. So what is the valency of magnesium? Magnesium valency is 2, Mg 2 plus. And the next one is oxide. So what is the valency of oxide? Oxide, see, oxide 2 minus. So Mg 2 plus and O 2 minus. So Mg 2 plus and O 2 minus, magnesium oxide. Then next step is cross give that value. So the 2 of oxygen will come to the magnesium and the 2 of magnesium will go to oxygen. So if there is a common number or if we can divide these numbers easily, then convert it to their smallest ratio. Here it is 2. So it can be divided with 2 so that it will be converted to 1. So convert to their smallest ratio. That time how it will come? 2 and 2 will get cancelled. It will change to 1. So MgO. This is the formula of magnesium oxide. Okay. So another example I am using that. Which example I will take? Aluminium oxide. Okay, one example I am using here, aluminium oxide. So first what we have to write? First aluminium symbol and oxide symbol and their charge. From the table you look at the charge of aluminium. Aluminium's charge is 3 plus. Okay, Al 3 plus. Aluminium charge is 3 plus because the valency of aluminium is 3. And oxide, now only we saw in magnesium oxide, oxide is 2 minus. And the next step is cross give that values. That time what will happen? 2 will come to aluminium and 3 will go for oxygen. So Al 2 and O 3. Al 2 O 3. We cannot cancel 2 and 3 because they are prime numbers. We cannot cancel them. So Al 2 O 3. This is the formula of aluminium oxide. Okay. Then I will show one more example. Which example I will take? Sodium hydroxide. Okay. Sodium hydroxide or aluminium hydroxide I will take. Okay. Aluminium hydroxide. So first of all we have to write the formula of aluminium. Then hydroxide. What is the formula of hydroxide? Sodium hydroxide, what is the formula? NaOH. Then what is the formula of hydroxide? OH. OH. Okay. Then aluminum's valency, now only I showed you aluminum's valency is 3 plus and OH valency. So in an element, if there is hydrogen anywhere, okay, anywhere, so many formulas are there, HSO4, HCO3, HOH, like that, which all elements where hydrogen is present, their valency will be always -1. They will always have -1 charge. Okay, wherever hydrogen is present, they will always have a valency 1 only. Okay, so now OH minus. So now what we have to do next step is cross give that valencies. That time 1 will come to aluminum and 3 will go for OH. So Al1, then here OH is there. If I am writing that 3 simply, that means this 3 is only coming to oxygen. This 3 is common for oxygen and hydrogen. So what we have to do? We have to keep that O and H in the bracket. AlOH thrice aluminum hydroxide. So 1 we will not mention usually. If you will write this 1 also, our answer is correct. Usually 1 we will not mention anywhere. So aluminum hydroxide. Okay. So this is the formula of aluminum hydroxide, AlOH thrice. If two atoms are coming together and if we have to give a number to that all atoms, we have to keep that atoms in a bracket. Okay. So this is the formula of aluminum hydroxide. Okay. Like this way we will be writing the chemical formula of given compounds. For that what you have to study? You have to study that table, which all I have marked, that all you have to study. Okay, daily study 5 points, then within 5 days you can finish it all. Okay, don't want to study at a time every elements. 5 elements you just study, then it will be easy to understand. Okay. So that is the making of chemical formula. Then next, how we will name a compound. Okay, how to name a compound. Okay. In page number 7 and page number 8, one table is given, the formulas and their names. Just to go through it, if you understood the first 2 table that I have marked, that table if you know means this table you don't want to by heart. Okay, from that table itself we can make all the elements. So naming of compound. So the first one is, if a compound contains one metal and non-metal, for example sodium chloride, NaCl, MgO, see, all are metals. First element will be always metal. Okay, if a metal and non-metal, second element will be non-metal. So if a metal and non-metal is present in a formula, how you will name? At the end of that name we will use IDE. So what is the name of NaCl? Sodium chloride. What is the name of MgO? Magnesium oxide. What is the name of CaCl2? Calcium chloride. What is the name of ZNS? Zinc sulfide. So see, at the last what we will mention? We will mention IDE at the last. Okay, IDE will be mentioned at the last. Okay, like this way, if an element contains one metal and a non-metal, how we will name the element? We will use IDE at the last. This one, what are the, how you will name a compound? It will not come in exam like that. Okay, one formula will be given like this way. Formula will be given and the question will be write the name of the compounds. Like this way only it will come. Okay, it will not ask how you will name a compound. This sentence and all you don't want to study. Just the examples you write. If a compound containing one metal and non-metal, this example you write and how you will name? At the end we will use IDE. Okay, so how you will name? First one is sodium chloride, second one is magnesium oxide, calcium chloride, zinc sulfide. At the last word we have used IDE at the last. Okay, then the next one is, if a compound contain only non-metals are present, like NO2, CO2, SO2, SO3, PCl5, then CCl4, like this. If a compound is there is no metals, all are non-metals. How we will name? These numbers 4, 2, that number we will mention. How we will mention? We will mention that number as di, tri, tetra, penta, etc. See, here it is NO2. What is NO2? Nitrogen dioxide. So what we have mentioned? Di, number of oxygen. How many second? The second element, how many times it is present, that number we will mention here. Here how many oxygens are there? 2 oxygen. So it is dioxide. This is CO2. What is CO2? Carbon dioxide. 2 oxygen. SO2, sulfur dioxide. Here 3 oxygens are there. 3 we will mention with a tri. So sulfur trioxide. Then here there are 4 chlorine. 4 we will mention with a tetra. Tetra. Okay. So carbon tetrachloride. Carbon tetrachloride. Then what about here? P for phosphorus. Phosphorus 5. 5 how we will mention? 5 we will mention with penta. Okay. Phosphorus pentachloride. Like this. So that a number we will mention for naming. If the elements present in a compound all are non-metals, we will mention the number with di, tri, tetra, penta, etc. Okay. So these are the names of that above given compounds. Okay. Then if a compound contains two other elements and oxygen, so that means 2 elements will be there and 1 oxygen will be there. So total 3 elements will be there. Not 1 oxygen, oxygen's number will vary. Okay. So if the number of oxygen is 1, if only 1 oxygen is present, what we will use? Hypo. We will use hypo. See, sodium hypochlorite. Okay. Hypochlorite. If 2 oxygens are there, means we will not use hypo, symbol sodium chlorite only. See, if the number of oxygen is 2, we will use only ITE, sodium chlorite. Understand? If the number of oxygen is 2, we will not use hypo, we will just write the chlorite only, sodium chlorite. Okay. If it is fluorine, means sodium fluorite. Okay. Like this, ITE we will use at the last. Then, if there are 3 oxygen, if it is 1 oxygen, means we will use the name hypo. If it is 2 oxygen, means we will use only ITE. Hypo we will remove. Then, if there are 3 oxygen, means what we will use? We will use ATE at the last. See, sodium carbonate, Na2CO3, sodium carbonate, ATE. At the last, we will use ATE. Sodium chlorate, ATE. Okay. Here it was 2 chlorine, that time we have used ITE, chlorite. If it is 3 oxygen, means we will use ATE, chlorate. Okay, don't get confused with ITE and ATE. ITE we will use for 2 oxygen, ATE we will use for 3 oxygen. If there are 3 oxygen, we will use ATE at the last, like sodium chlorate, sodium carbonate, etc. Okay. Sodium chlorate, sodium carbonate. Then last, if there are 4 oxygen, how we will name a compound is, we will name per in front of the, after the first element. After the first element, we will use a per. Sodium perchlorate, sodium perchlorate. If it is iodine, means sodium periodate. Understand? ATE and per we will use. Okay. So this much only naming of compound. Okay. Today we have completed how to write the chemical formula of a compound and how we will name a compound. So go through these portions, read your textbook clearly. If you go through, if you have any doubt when we are coming to school, mention the doubt in your note textbook itself, and at the class itself you can ask to me. Okay. So thank you all of you. Take care.